I appreciate your time today. I've been in the electric motor industry my entire life. Um, my father started me back in when I was really young, rewind electric motors about 10. Since then, I've been now 65, and I've been doing a lot of different things in controls, motors, my entire career. And I really feel it's a time in my life that I really want to give back of information that I've been gifted with by many people that give me a lot of information that have really helped me. And I truly believe in what Zig Ziglar talks about, is that if you can help everybody else in life, you'll always have exactly what anything you would need in your life. And that has worked for my life very extremely well. Zig Ziglar has been one of my mentors. Sad to lose him about almost like 12 years ago already now. But I started, my father started our company back in 1953, installing wind chargers in Nebraska. In 1971, he was actually a businessman of the year. He had started several manufacturing companies. Several of the motor companies are still in operation under other family members. And I still, at this point in time, have sons and daughters, in the industry. I spent 40 years working with very closely the utility companies on applications of controls, variable frequency drives, soft starters, and those type of things to do evaluations. Electric motors do consume over 70% of the world's power, and they can be impacted if properly, the loads are properly balanced to the application. And that's what the advanced capability of the new controls that are out into the market today that can be extremely helpful and create very strong efficiencies for the motor. And the real issue that people forget about is that the motor purchase price is only 5% of the cost compared to what its electric consumption cost is. So it's important to look at what that system efficiency is, whether it be a pump, a fan, blower, and conveyor, whatever it is, gearing, to look at that system efficiency. And I give a lot of webinars over my time in pumping, gearing, submersible pumps, vertical hollow shaft motors, and those type of things to help industry. I spent several years in the 90s working with the Department Electrical Power Research Institute, very heavily involved in plastic processing machines back in 1993, where we applied these to injection molding hydraulic pump systems, and saved a lot of power, and proved out the opportunity for adjustable speed drives. A mentor of my life is Nikola Tesla. Studied many things of his in his lifetime, and I really believe that if we continue on with what he had started and continue to advance, I'll just play this little video here real quick. Some of you may have heard it if you've been on my classic course.
When you think of electricity, you think of Edison. But there is one electrical genius who is nearly forgotten. A man who dreamed of giving the world an unlimited supply of energy. His name was Nikola Tesla. This is the story of a modern Prometheus who changed the world with electricity. It was Nikola Tesla who captured the power of Niagara Falls with his alternating current system and made it possible to transmit electricity to all of America and the world. Suddenly knew he could recreate this rotating field by powering the coils of a motor in different steps or phases, like the pistons of an engine. The resulting forces of magnetic attraction and repulsion would literally twist the rotor in a circle, the electrical equivalent of the wheel. And all this was accomplished with alternating currents.
So what I'm talking about is the real understanding of how electric motors work. Nikola Tesla originally, created the induction motor. He originally did it on two-phase, then over time created three-phase, and from that, has evolved, a lot of different motor types that are out there. But the real issue is that an induction motor wants to run at a single speed because it has a fixed number. Like this had to be a 4-pole machine. So if you hook that to 60 cycle power, it will run at the rotor inside will run at about 1800 RPM, synchronous speed. It still has some slip in it, but what's been happening for years is that you've got your three-phase power, coming in against a induced north and south pole, and it literally makes the rotor turn. And by having three-phase, it will self-start because you have one here and then the other one, kicks in right after it, as they're, separated apart in their phases. It'll make the motor turn. What's happened, over the years is that there are a lot of applications where there are, the power company brought, three power lines coming in from out, in their source, dropping them through transformers and giving them full three-phase power, directly to the motor. But there's also a lot of single phase out there where they put on one transformer, there's only 2 lines of power coming out, and then they have a ground neutral, so you have just 2 wires here. So the three-phase, you only get 1 sine wave on a single phase source, or you have 3 sine waves on a 3-phase source. And when it hooks directly, this shows the transformer, wiring. You can pull just a single phase load off of it, either line to neutral or line to line, and get single phase for it, or you can pull all 3 phases off by going, each phase to line. So in order to make a single phase motor work, they have a main winding, which basically runs off of the sine wave. But in order to get it to start, they always have these start capacitors. And literally what they're doing is they're building 2 phases of power then to get the motor, back to our drawing here, to get the motor, they have another set of windings in here. In order to get the motor to start, they have to have that power kick in via capacitor. So capacitor in the circuit actually makes a phase angle because capacitors lead and inductors lag. So the actual capacitor makes another phase. So you end up having like a 2-phase motor. So the capacitor, kicks in until the centrifugal switch. This is the start capacitor, give it like a little boost. And then a run capacitor is literally make it run 2 phases. So this winding still has some power through it. The issue is that single phase motors are really about 70% efficient. They don't have the balance of 3-phase, and they don't have the capability of getting the optimal waveforms. So the motor tends to have to be bigger. The rotor has to be bigger in order to get it to start and run. And the efficiency levels, some of the older ones were like in 60s. Now they're, pushing up more around, depends on the horsepower. It can be, anywhere from, 70 to maybe 80%. So there is an advantage to using 3-phase motors on the efficiency. Some of the newer efficiencies of motors are running, on a smaller machine. They can be about 85 to 90% efficient. On a bigger machine, they can be as high as 95% efficient. So what we're talking about here is the two different types of motors that exist in the marketplace. In most applications, this covers about 90%, the world's market. There are also servo motors, self-reluctance, multiple other types, but the main workhorse of industry, is a three-phase induction motor. So again, back to, we've got the rotating fields here, and in order to have a single phase do it, we have to have start capacitors, and get it up and running. So what we're talking about today also is what they call phase converters. And they're taking a regular induction motor that has, all three phases here, all three phases in the windings. And what they do is they simulate, this is called a static phase converter. And what it does is, again, it simulates putting capacitor in to start it onto one phase. And then it has this run capacitor that sits there and feeds it. And then has another capacitor that comes off the other line to feed that third leg. And that all that is to create a phase shifting so that the motor can actually get up to speed. The issue is the efficiency of this is very poor. It's okay on machine tools that have very, very light loaded, but if you're trying to get any torque out of the motor, a static phase converter really doesn't do much for you and doesn't really give you, very good power quality. The other that's very heavily in the market is what they call rotary phase converters. And literally what that is an induction motor with the shaft cut off. And because when a motor is up to speed, it actually, when a motor gets up to speed, it creates a rotary transformer, meaning that it puts in counter EMF voltage, back to the circuit. So literally what this is, these are the run capacitors in there. These are the start capacitors, and they're bringing this up to speed. And then they have like a time delay. Sometimes they use time delay. Sometimes they use, voltage sensors. But what they're doing is they're basically powering up from the line power here, line 1, line 2. They're powering up line 1, line 2, get the rotary transformer running by putting in start capacitors and then run capacitors. So it's literally a single phase device that gets that rotary turning. Then after it's up to speed, these start capacitors drop out, and then it provides three-phase power. The problem is that you've got inefficiency losses of running this rotary transformer. You got, some losses in your capacitor. Plus, again, you can't get the balanced phase angle. So from that, the thing that you have to really, really be careful of is when you run phase converters is how balanced is that all three phases that it's creating. And typically on a standard phase converter, it's not very balanced. If you measure the voltage, line to line, the phase angles are never quite perfect. And so you should be derating using the motors that you're using on those three-phase motors. You should be derating them. If it's off like even 5%, you're supposed to derate it 25%. But there's a lot of motors out there, and they keep wondering, well, why do they not last as long? Why do they, burn up? Why do they, have problems? A lot of it has to do with the motor design itself, or the phase converter design just is not giving, true balanced three-phase power. And then that also affects the efficiency level. And what I want to bring up is, I've been involved in ESA pretty much my entire life, which is the Electrical Mechanical Authority. They're out of St. Louis. Our motor companies are all, part of this. And they're a group of about 2,500 in the United States, and worldwide there's well over, 4,000 companies that are involved in this. Everything from manufacturers to, electric motor people, electric motor rebuilding people. And they've came up with a lot of standards. This was started in 1944. My father used to be a past chapter president and a director of this group. My brother also was on the director of that. And they've got a lot of really good information to help you, even on, centrifugal pump applications, volumes, flows, to give you, get back to those efficiency points. They have a lot of data so you can find out what truly caused motor failure. So this happened to be, you can see that the imbalance in phase power on those three phase, or those, this is going to be a 4-pole winding. You got one set of windings here that weren't very well used. That means that this motor was being loaded on these phases heavier than it was on the other, and over a period of time, an imbalance, just smoked the winding. There's spiking issues, when the voltage transients, between phase to phase, and this is a very handy tool. You can get that, a copy of this, if you want, also. And then the next version of phase conversion that is, in the market today is that it's transitioned to electronic. And what that really came from is these patents that were written by Nolan back in the 60s and 70s. In 1975, he had patented the technology for NASA on variable frequency drives. And it was a great help to our world. And from that, has now came out, this is a very simplified version. And I think that many manufacturers try to make it more complex than it really is. And it really, drives up cost. I see in, a lot of other countries, they're not pushing the, necessarily the brand name quite so much, but what you really literally have is, with the invention of the transistor, this happens to be an IGBT type transistor. What that allows us to do is to bring in those three-phase power or single phase into the circuit with a capacitor. We're building DC power. Then we're able to bring true, it's not true sine wave power, it's called PWM, and then it has the current waveforms end up being sinusoidal. So the benefit to this is that it actually allows the motor to run properly on all three phases, because then all of these phase angles between the phases are directly in time with each other. So you don't need to derate the motor. And the motor will then, provide torque and power. You also then, get the advantages on a lot of phase conversion. There are ones that are out there that are just simply straight phase converters. They're not using them. They're not using the, the front ends on them that actually can then regulate the PWM. They're just bringing in the power and bringing three-phase out. Typically, you have to, if you're not using it for a motor, that's okay. But if you need it for a motor, you just will take advantage of it and, utilize the other, advantages of it. So literally what we're doing is, instead of, taking like the static type where we're just using phase shift capacitors in here to get it up and running and then doing it, but the phase angles between them all, you really need to derate this motor by, about 25% that you're running them off of. With a rotary phase converter, the same thing. You probably get by with a 15% deration on some cases, but you really need to look at that load. And you've got extra capacitors and things in there that are, options. And then you have the, the actual, what I call more the VFD design, or electronic in the marketplace out there that allow you to build through three phase to the motor. further. And from that, back to the efficiency point is that, so it's important that, amps times volts basically create power. And so the three-phase motor being more efficient than the single phase, you can pick up 15 to 20% more efficiency by using three-phase motors and putting inverter technology on the front of them instead of doing the other. And you see a lot of that happening more and more today. We actually have units that are, single phase rated input, give you three-phase out, and they'll mount directly onto the motor, and that's up to about 15 horsepower now, and they're watertight. You can stick them right on the motor. They, have heat dissipation. They're made, aluminum housing, so they, they self-cool themselves. We use those a lot. We also have a lot of watertight. This happens to be a little bit about, we build our controls so that they can mount in the marketplace. Pumping software, operating right on the front of the nostril and watertight, so you can mount them out into the application. Take single phase in, three-phase out. They also have pumping software inside of them, so that operate. They have all the capabilities of but they are capable of running on single phase. Do this, they're up about 50 horsepower. We are capable of running on single phase. We go all the way to 55 horsepower. But we have a lot of modification capabilities, when they come out. See. So again, motor consumption, in the world is a very big factor, and there's a lot done out there with, pushing solar, wind. But my feeling is if we attack this, motor utilization of 70% of our world's power, if we attack that and reduce that, we don't have to do as much generation. And so, HVAC uses 15 motion, on industry and those things is about 51%. Lighting is about 16%, about 14%, is electronics. So the real key is to slow these darn meters down. And you do that by putting a control in between the motor and the drive. Also, the thing that's done today is the controllers are also able to take direct DC off of the power source, off of a solar system. So if you've got batteries or those things in on a regulated circuit, you can actually just there's two terminals in there. We can bring DC, directly in. We put an extra protection diode in between, but a lot of that's being done today. And then there's software that actually can regulate the reading of that solar, and it can be pulling off of the solar or it can be pulling off of the power source, either single or three-phase. So it's made a lot of flexibility. I do also give classes on power quality and those things, because because we're now a non-sinusoidal, input power source. We also have stuff to, basically help clean up that, that power quality. Sorry about couldn't hear the video when it was running. I'm not sure what, when I'll send out a copy of the video to you, and it'll have so you can actually listen to the videos. Sorry about that. Maybe I had one of the things shut off. It was on the notes there. What I'd like to do is go ahead and open it up to questions if you'd like. You can either send me a note and I can answer them on, in the chat, and then answer those questions, or I'd be more than happy just to, there's not a real big group of us today. There's only 11 in the group. So, I'm glad to open up to questions or, give feedback, or, if I don't know the answer, I've got, thousands of friends out in the marketplace that, can, possibly help with your question if you'd like. And that's why I highly recommend, I did put in the chat of how to join the Nikola Tesla. Here we go. I put the group here. You're more than willing to, some of them I know may already be, in that group, but please join it. A lot of people have given a lot of information and helping everybody. There's so much information in the world. They figured out that we can unlock about 10 billion, years of knowledge by just more sharing of concepts, ideas, and getting proven solutions that have worked in the market. And sharing what did work, what didn't work. I do have what I call Tesla's Bible that I found in a bookstore up in upstate Maine that was written in 1904. It's got pretty interesting information. I was also able to have several mentors and things that I used over the years that taught me in colleges that were with RCA, and they dug back clear to the Tesla information and have helped. So feel free to ask questions, and I appreciate everybody's attendance today, and I'm like I said, open for questions, so go ahead. Yeah, I had a question from says P here. I have a 5 horsepower table saw that he has single phase power in his workshop. Will inverter make that work? Yes, definitely will. If you're not going to be using the table saw very heavily, you could get by with a static converter, but a variable frequency drive will give you full torque and power for that, and make the motor run more efficiently and operate and last longer. If you'd like, just send me an email. I published my email address there. Yeah, I'd be glad to send you out some information on that. But yeah, definitely that would work simply for you to do that. And you would use your 230 volt single phase that you have from your circuit breaker, bring it in, and then I could help you if you need a little help with the wiring on it. Just send me a few pictures and an email, and I'll help you back give you some help. So thanks again. Some of the other tools that I use in the marketplace for complex applications are also these Fluke power meters.
Introducing the Fluke 438 Power Quality and Motor Analyzer. The Fluke 438 is a multi-purpose test tool designed to improve troubleshooting on electric motors and minimize downtime. Whether you're in a process plant or discrete manufacturing, electric motors are critical to your operation's success. The Fluke 438 lets you quickly gauge electrical performance, power quality, and mechanical performance of industrial motors. Using 3-phase electrical measurements on the input and motor rating plate data, the 438 calculates torque, the most critical mechanical performance variable, speed, load on the motor shaft, and overall efficiency, without the need to install mechanical sensors. All this with a single tool, and all while the motor is running so you don't sacrifice uptime. Power quality issues, such as unbalance and harmonics, can cause motors to run hot, eventually stressing windings and accelerating failures. Motor failures lead to costly downtime, and the cost of waste associated with inefficient motors adds up. When testing direct online motors with the new Fluke 438, you get both power quality information and mechanical performance data in the same test with a single tool. With an intuitive user interface, optimized current probes, and at-a-glance motor status screens, the Fluke 438 gives you the motor troubleshooting information you need to make better maintenance decisions and keep your plant up and running.
So the reason we use that a lot is, they mentioned in there, it checks those balances, going out to the motor. So even if you have an inverter or don't have an inverter, it's very important that your power company is giving you, very balanced power, because, you lose a lot of efficiency by that imbalance in those phase converters. Here's a little bit of my contact information. It's engineering@AC-DC-HOTLINE.com. And we get involved in a lot of motors, controls, building specialized control panels, and those things, and we're glad to help you in any way we can.